Hi everyone, my name is Abhilash Thomas and I'm going to be presenting about AI and big data. I'm going to be presenting, I'm going to try and present in a little bit more fun way. There will be some memes along the way, but those memes also have their own sort of addition to the slides because they convey their own information through the slides. I hope you enjoy, but at the same time also understand and learn a little bit more about AI and big data. So let us try and understand what big data actually is. What is big data? So this is how Oxford Dictionary defines big data. Big data is essentially an extremely large data set that may be analyzed computationally to reveal patterns, trends, and associations. So I believe that everyone would know uh, what a big data essentially is. It is basically data uh, that has a lot of contents in it. uh, we'll actually see more features about the common characteristics of big data. So these are usually the most common characteristics of big data. We can go through them one at a time. The first one is volume. Of course, big data, by the name itself, it means that there is going to be a huge volume of data that is there. Variety. Variety, of course, it's like it won't be the same data again and again, seeing different kinds of data that have something different in them. It's not like we are writing the same data 1,000 times. There is some differences in those data which can be analyzed. Velocity. Velocity here refers to the rate at which data is being added in this. So big data usually a continuous stream of data that is coming in, that needs to be analyzed, that has information and knowledge to be gained out of. So that is there. Veracity essentially means that the data is consistent, it can be verified, it is not just fictitious data, it is actually data that is being measured, and that is what veracity is. Value, yes, the data that we are storing, that we are analyzing, it has something worth analyzing, worth understanding. There are going to be some benefits or advantages of using those data and understanding what those data represent and what they are trying to convey. Atomic, it means that the data can be expressed in a granular form. Like uh, it is not a continuous stream. There is this continuous stream of data, but within that stream itself, there are certain sections that we can analyze, that can be isolated from the rest, and those data can be individually analyzed and understood. Relational, of course, means as we understand in the terms of database, the data that we have collected, they have to be related to each other, which is how we actually infer the uh, information, and it's not data about non-related things stuck together. The data in big data have to be related to each other. Extensional basically means the big data that we have right now, it can be extended to have more additional data. So for instance, like if we in the big data that we have, it has like 10 columns right now, and maybe in future we realize and we understand that there's another point of data that we need to accurately measure to get better information out of it. So we start measuring that new data, and that new data can be added to the existing big data, and it should make sense. Scalability, of course, means that the data can be expanded, and it can be as time progress, we start having more big data, like the data that we have, it increases exponentially. So we should be able to effectively uh, analyze and use that data. So after gathering all this data, let us understand now how like big data and AI help. So as we know, data is right now unstructured. So to get information from that data, we have to somehow structure it. And once we get that information, then we need to gain knowledge out of that data. So typically what happens? A computer is responsible for storing the data, and the human actually structures that data, and the human infers the knowledge from the data. So basically, computers just store the data. The human is responsible for getting the information as well as gaining the knowledge from that data. So how AI comes into this is, instead of humans getting the information and gaining the knowledge, the AI um, themselves start getting the information and the knowledge without any human intervention. Why? Because we have a limitation that humans cannot process uh, big data, meaning complex data as fast as the computer can. So if the computer can infer from the data and gain that knowledge, then it will of course be much beneficial in the long run. So like in the photo that I have, uh, a computer knows that a dog has pointy ears, it has a nose like this, it has an eyes like this, it has a tongue like this, and it's a face similar to this. And then when we show a picture of a cat, it will infer, oh, this is a dog. I know it has everything that the dog has. But so that is what a major hindrance of the development of AI is. It is something what we humans infer as common sense, but AIs do not have that. AI is like a child. A small child would not know what the difference between a dog and a cat is. It might be obvious to us, but it's not obvious to AI. It is not obvious to a child. So just like a child, we correct them. We tell them this is not a dog, this is a cat. And the same way, we tell the AI that this is not a dog, this is a cat. So then it looks into that data. Okay, so if this is a cat, what is over here, present over here, that is not present in the dogs, that is making it different? So it can probably analyze that the cats have a more prominent whisker that the dogs do not have. So that way, next time when it sees a face that is similar to a dog, it will also check if it has like long whiskers. Then it will be able to correctly identify that the dog is a cat. I mean, the photo of the cat is not a dog, but it is in fact a cat. So it gets with, as is written over here, it learns from the data and it predicts what's going to happen. It's much faster than any human. It performs actions much faster than any humans can do. And as time progresses, it keeps learning more and more. It is like a human that never dies and it keeps on gaining knowledge. It never loses its memory. So it's always going to be much better and faster than a human. So that is where big data and AI together can help us. So what are the possible use cases for big data and AI? So one of the main things that we see with AI and big data is it helps to spot the business trends. And so this is being used by all the major corporations, Amazon, Google, you name the company, they're analyzing their customers' purchase and behavior patterns, and they are planning their entire inventory and their business according to the data that they have. Even the law enforcements right now, they are using big data. They analyze how people commit crimes, what happens in riots, how to prevent those crimes from happening. And the third one is, of course, preventing and curing diseases. This we saw when COVID was at its peak. Scientists from all across the globe were sharing information with each other. They identified the genome sequence of the virus in such a short time, and they worked on together with each other to get the vaccines. So that is also thanks to big data and AI. Design machines, yes, of course, complex machines. They are designed. They can be designed by. They are designed by big data and AI. In fact, there is an interesting project going on where scientists are trying to create a robot that is able to create itself with if it is given the raw materials to create itself. So it's basically like a robot that can bootstrap itself. And if given enough resources, that robot can create an army of clothes, which which would look straight out of some sci-fi novel. But it is true that is happening right now. The next thing, of course, is space launch. There are like millions of calculations going on over there, and uh, the AI not only does those calculations pretty fast, but they are also able to respond to the calculations in a much faster manner than a human can. We also know the Large Hadron Collider that is working on nuclear physics, that is trying to understand the basics of atoms. So they also have a huge data and AI over there. But the thing that I'm going to be focusing more on this in this PPT is going to be the weather forecast. So why do we forecast the weather? So there are many implications of weather forecast which we traditionally do not consider. We just consider that, oh, weather is just for us, like we know whether it is going to be cold or whether it is going to rain. But no, weather forecast is of utmost importance in all of these facets. The weather forecast will tell when the farmers should sow their seeds and when they should harvest. If the weather forecast is wrong, there the farmer can lose the entire crops. Like if it snows before the farmer expects, then their crops would get destroyed and they would lose their entire year's worth of hard work. So that is pretty important. And not only that, the food that they make, it's coming to us and it could lead to food shortage and inflation. So it can be a chain effect. Like if you don't get the weather right, it can throw the entire ecosystem into many. The second important thing is, of course, marine trade. We know that majority of supply chain in the world is happening through marine trades. So not only is it important that lives of the people who are on the ships remain safe, but also that the millions of dollars worth of goods that are traveling on these ships, they remain safe and they arrive at the destination on time so that everything runs smooth. Energy management is another important thing. Like it's very important for the city and the county to know what the weather is likely to be so that they can manage their energy production accordingly. Like if it is going to be really hot and really cold, then we know that the energy consumption of the average person in that city is going to increase. They're going to need either heating or cooling depending on the weather. And if the weather is good, then we know that uh, the energy consumption is going to be lower than usual. So using that, whether they are able to accordingly manage the energy consumption. Transportation management is also important. Like the city would need to know if it's going to rain, then people who usually walk or cycle, they would need to take the public transportation, and the civic body over there, they need to prepare accordingly for that, and they need to ensure that the buses and the public transportation is available there for the citizens of that area. Civic management, of course, they need to know whether it is going to be heavy rain or heavy snow, so that accordingly they can ensure that the roads and everything else is safe for travels. Sports is another important thing. Many expensive sports events, they invest heavily into understanding what the forecast is likely to be during the time when the sports event is to be held, and accordingly they also adjust the schedule if they understand that it is likely to rain and cause disruptions during that day, then they adjust the schedule accordingly, and to prevent bigger losses than actually losing the sports event on the day itself. Uh, the last topic is something that I'm going to go a little bit more deep on, which is the disaster management. It is the most obvious one. Everyone needs to know whether a cyclone is coming, a hurricane is coming, or it's going to rain, it's going to flood, or it's going to be like a hailstorm. So that's something that we always need to be aware of, and we need to take proper precautions for. Okay, so this is actually a forecast of Hurricane Sandy. So Hurricane Sandy had just crossed Cuba, and it was going through the east coast, and it was predicted that it would not enter the US mainland, but it would just skirt across the east coast and go through. That was what was predicted. And if you want to see more predictions, we can go to the next slide. So as you can see that this is the blue line, this is the yellow line. So these were predicted by the US agencies. The red line was predicted by a college in Princeton, in New Jersey, and the green line was predicted by Japan. So you can see that there's a huge difference in what the prediction is, and we don't know exactly what's going to be. So we need to know these things that will help save the life. So the same thing, if you can see over here, you can see that it's here at around 2 p.m. and this is what is predicted. If everything goes according to what is predicted, then we are able to manage. But you can see that the red line over here, sorry, I mean the black line over here, that was the actual path that the hurricane took. So it went over here, and then it took a sharp turn and entered back into the main. That was something that nobody predicted correctly. And as we know, that Hurricane Sandy caused great devastation both mankind, as in like livelihoods were lost, many lives were lost. There was a huge implication for the people local to that area as well. So this is, I am showing you this because we need to understand that how crucial big data and AI is in terms of saving lives. So now I'm going to talk to you about how uh, data is collected for weather. So data for weather is actually collected from in a variety of ways. We have satellites that are above us that are always keeping a watch on how the clouds are moving and how the weather is going, how the storms are forming. We also have like temperature, pressure, humidity, precipitation sensors all across the globe, all across the continents. In fact, uh, but I'm going to be focusing on uh, a, a, a technique for data collection that interested me the most, which is the usage of weather balloons. So how they do it, they actually release like 900 balloons all across the world at the same time twice a day. And this balloon goes from land till up to 10 miles. And throughout that journey, it floats in the air from left to right, from left to right, depending on where the what the altitude is and what the wind current is at that altitude. It moves, so it keeps track of the entire movement, and so in that way we get a more accurate information of how the wind is flowing from one area to other, from one altitude to another altitude. It also measures like the pressure, the temperature, the humidity, everything it measures, and it gives more in-depth information than what of that area than any satellite or any device that is there on the land can provide. So it has a device called the radiosonde, which is attached to the balloon which goes up, that is responsible for measuring all this data. And once it reaches 10 miles, the balloon just opens up, releases the gas, and it the radiosonde falls down, and the parachute that is attached at the bottom, that also opens up. It is not necessary for the radiosonde to be collected for us to receive the data, because the data is being sent wirelessly as it is up in the air. So the advantage over here is like it gives us different readings for different altitudes, which is also very important for air transport, because that's the altitude where the flights are going to travel, and it's important that they are extremely safe and they avoid areas where there is high turbulence. Now I'm going to show a small video. This is not the actual weather data. This is a study. This is just a simulation that is done by University of Michigan, that measures the humidity, basically the cloud formations, and it is doing the simulations basis on different data that they have collected. But what's important over here is, right, so let us watch this video as it goes. So you can see that from it's actually collecting data right now at every 25 kilometers. That's what they have claimed. So they are measuring how the um, hurricanes are being formed over here and here, and how the winds are being passed, how the Antarctic airs is going. They have also given us a comparison over here, which is more interesting. So what you can see over here in top is when we are measuring these humidities at every 200 kilometers. And at the bottom is when we are measuring at every 25 kilometers. So the difference over here, as you can see, that if you compare these two images, they are similar, but the analysis at the data, the accuracy of the data that we see for the 25-kilometer one is much better, right? So it shows how the air is flowing for the top one as well, but in the bottom one, we see the intricacies of what's happening in between those areas. So this is the difference when we have like better data, in-depth data, and we'll be able to get even more better predictions instead of like failing the prediction when we did for Hurricane Sandy. So now what happens to the data that is stored? So after the weather forecast is done, the data that we have collected, it is still stored. The data is currently being stored in a website called for Climate Data Online. We have over 100 years of weather that is available, and anyone can access that information. And this is even more relevant right now, because using those data, we can definitely see the impact that global warming has had on the ice caps, as well as the glaciers that are there. The lakes are also drying out. So these are all important information that we can see, and we can analyze what's happening, what's changing, and take corrective actions before things get even worse. So finally, big data is actually invaluable right now in the current environment. It is happening whether we like it or not. It's always there. Big data is used in every single thing that we see right now, and it's a part of modern civilization, and it's not going to change, at least for the foreseeable future. In fact, it's going to gain more prominence, and we would be seeing AI and big data working together in collaboration to make the lives of humans better and safer. So I hope you enjoyed my presentation. Thank you, and thank you for attending.